Okay, let's continue on here in chapter 8. Today we're going to talk about the sum and difference identities. These are the sum and difference identities for cosine and sine. If you'd like, take a moment, pause the video now, and write these down so you can refer back to them as we go through for your you-do examples. A couple of things to note here for the cosine. You can see that we have the cosine of the sum of two angles, alpha and beta being two different angles, and it turns into the cosine of alpha times the cosine of beta minus the sine of alpha sine of beta. So it's two cosines together and then the two sines together with the alternating angles. And when you do the cosine of the difference, it is plus here, but the formulas are the same besides that. When you get down here to the sine, you see that it is actually the sine alpha cosine beta and then cosine alpha sine beta. So for me, that's the pattern that I always write it in. You might see it in your text as sine beta cosine alpha, but this is the way that I memorize the pattern. So this is how I do it. Okay. All right, so really we're just going to be applying these rules. Now, to be successful using this technique, you have to keep in mind the common angles that map back to your reference angles. And so here's a list of the angles all in radians. Of course, I want you to try to think in radians as much as possible. Of course, if you're having a difficult time, convert everything into degrees if necessary. You can go through here and figure out what all the degree measure is for everything and have yourself a nice, beautiful list to deal with. I am going to start the example with some degrees here, and it asks us to find the exact value without a calculator. And so you have a couple of things to decide here. Are we looking for the sum or the difference? So you can think about it a whole bunch of different ways. I always start with my reference angles, right? And let's just remember what our reference angles are. So the angles that we're going to deal with generally are 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So if you write them down and actually visually look at them, it makes it a whole lot easier to think them through. So here we can say that 30 plus 45 is 75. All right, so that's what we're going to use. Now, the formula for the cosine of a sum is, so the cosine we'd write of 30 degrees plus 45 degrees is equal to, and we do cosine minus, so you change the sign, sine. So this is going to be cosine of 30 degrees times the cosine of 45 degrees minus the sine of 30 degrees and the sine of 45 degrees. Now expect that you're going to get some really ugly numbers out of all of this. So this is equal to the cosine of 30 degrees is 1/2. The cosine of 45 degrees is the square root of 2 over 2 minus the sine of 30 degrees is square root of 3 over 2, and the sine of 45 degrees is the square root of 2 over 2. Now I think we've dealt with some of these really ugly numbers before, but let's just clean this up here. So we get root 2 minus root 6 all over 4. Okay, now you're going to find that the challenge here is not plugging and cleaning it up. The challenge here is going to be thinking about what two values of pi can give us 2 pi over 3. Okay, and you're going to have to kind of struggle with this. This is why I gave you that nice list. You're going to have to kind of look at the list. Now keep in mind here, if our the main denominators, I'm only going to talk about the denominators that we're working with, is we work with over 6, over 4, over 3, and over 2. These are the denominators that we're working with, and we need to get a denominator of a 3 out. So that means that we could be working with 6 and 3, or we could be working with 6 and 2. Okay, but we wouldn't be working with 3 and 2 or 3 and 4 because we wouldn't be able to get a common denominator that would give us that value. So that's just kind of a good place to start. Guessing and testing is good as well, right? But also, when you very first start doing this, I'm going to suggest that you might consider converting the angle from radians into degrees so you can think that through. Now, I'm not going to do that. That's on you to work with, because if you don't struggle and build the pathways in your brain, then you won't learn this or retain it. All right? So we're looking at the sign here, and I'm going to tell you that we're going to have the difference in 2 angles. And the angles that are going to work here is going to be 3 pi over 2 minus 5 pi over 6. Because 9 minus 4 over 6, 4 over 6 is 2/3. So this is going to actually give it to us. Okay, so we're going to be doing the subtraction here. And so this is going to be equal to the sine of 3 pi over 2 minus 5 pi over 6. And when we apply the rule there, that is the sine of the first angle times the cosine of the second angle. Signs stay the same. We're just flipping. We flip the trig signs around. The trig functions around on the sign, so we leave the sign of what's happening. Sorry, so many signs. It's really hard to talk about trig sometimes. As the same. So now we're going to say minus, and we're going to say sine of, we've already picked up 3 pi over 2, so this one's going to be the 5 pi over 6 times the cosine of, we already have the 5 pi over 6, so I'm going to go 3 pi over 2. All right, and then let's just figure that out. Well, what is the sine of 3 pi over 2? Oh, what if we're not sure? Let's just draw a picture. So this is 2 pi and this is pi. So 3 pi over 2 is going to be -1. Cosine of 5 pi over 6. 5 pi over 6 is in quadrant 3. So the cosine is going to be negative, and the cosine of pi over 6 is square root of 3 over 2. So this is going to be equal to negative square root of 3 over 2. Minus, and now let's do the sine of 5 pi over 6. Sine of 5 pi over 6, that's in quadrant 2. Oh, I'm sorry, this is quadrant 2, but it's still negative. This is in quadrant 2 as well, but it's going to be positive. And the sine of 5 pi over 6 is going to be 1/2. So that negative holds from here. That's that negative. All right, and then the cosine of 3 pi over 2. Oh, let's draw a picture of the cosine as well, just so we can remember. There's 2 pi. There's pi. So the cosine of 3 pi over 2 is 0. So when we finish this out, our answer is the square root of 3 over 2. All right, so sometimes it's pretty, usually it's not. So keeping it with kind of on the simpler side, I'm going to give you your first quadrant radian angles, and I'm going to have this first one be a u-do. Now, I know I've said this before, but if the pi's are messing you up, do it without the pi's and just do it as a fraction. Okay, so let me list out what our radian measures are. We'll have pi over 6, pi over 4, pi over 3, and pi over 2. So out of these, we need to find the cosine of pi over 12. So we know for sure we're going to be looking at subtraction of two angles, because this is 1/12. All right, you're not going to get that from adding two angles together that are commonly known angles. Remember, we're only working with the angles that you already know. So that's the reference angles and all of their counterparts all the way around the circle. Okay, so I'm going to give you about a minute. See if you can't figure out which two of these values you need to find pi over 12. Again, you could also say what plus what equals 1 over 12 and eliminate the pi's. Okay, so hopefully you have figured out that it is pi over 3 minus pi over 4. That's equal to pi over 12. All right, and then we are dealing with subtraction of cosine. So we're going to have cosine of pi over 3 minus pi over 4. That's going to be equal to the cosine of pi over 3 times the cosine of pi over 4 plus, because the cosines, we change the sign here, and then we'll have the sine of pi over 3 sine of pi over 4. All right, so let's see what that turns out to be. Cosine of pi over 3 is 1/2 times the cosine of pi over 4, root 2 over 2. This time plus sine of pi over 3 is root 3 over 2. Sine of pi over 2, root 2 over 2. You might be like, this is the same problem. No, it's still not, because this is root 2 plus root 6. The last one was minus over 4. Okay, let's take a look at one more before we move on to the tangent. So taking a look at this one, we have to think about what two angles could add together to be 13 pi over 12. And like I said, I would love it if you paused right now and did some of that work and thought about it. But I am not going to force you to. This I'm definitely going to do with addition, and the two angles I'm going to use is 5 pi over 6 and pi over 4. All right, so this is going to become the sine of 5 pi over 6 plus pi over 4. That's equal to the sine of 5 pi over 6 cosine of pi over 4 plus the sign stays the same with sine, and then this will be cosine of 5 pi over 6 times sine of pi over 4. And then let's just figure this out. Of course, sine at 5 pi over 6 is quadrant 2, so it's positive. Cosine 5 pi over 6 quadrant 2 is negative. I always make those notes so I just don't forget. Okay, so sine of pi over 6 is 1/2 times cosine of pi over 4, root 2 over 2, plus cosine 5 pi over 6 is going to be negative root 3 over 2. Sine of pi over 4 is root 2 over 2. So here we wind up with root 2 minus root 6 over 4. Completely different angle. I believe even a different function than the last one we got like that. Let me look at my notes real quick because I can't go backwards. Yes. Okay. So there is a special formula for tangent, and as you see here, it is the sum of tangent A plus tangent B over 1 minus the product of the two. And then the signs change, so the numerator follows with whatever the action is in the argument of the function, and then you take the opposite sign on the bottom. So let's do this one. Let's see here. We have 11 pi over 12, and we can do that with pi over 4 and, right, because pi over 3 gave us that pi over 12, right? So what is pi over 3 plus pi over 4? This is often the way that I'll do it. I'll come up with two of the numbers that's going to give me the bottom, and then let me see if I can manipulate them, right? So this would be, if it was over pi over 12, this would be 3 pi plus 4 pi is 7 pi over 12. That's what this is. Just trying to show you a way to think about it. So what could we change? What if we put a 2 right here? And that's my first inkling, is to double that one, and then if that didn't work, then I'd come over here and say, what if it was 2 pi here and that pi over 3? Doesn't make sense for it to be pi 12s on the bottom though, so that doesn't really work. So you just have to kind of work it through. Some people are way quicker and better at this than others. But if you look at this, then we'll have 3 pi plus 8 pi equals 11 pi over 12. So yeah, that's awesome. There it is. All right, so those are our two angles. So this is going to be the tangent of pi over 4 plus 2 pi over 3, and so it's the sum, so we're going to deal with this top equation here. So that means that we're going to go tan of pi over 4 plus tan of 2 pi over 3 over 1, and then now it's the opposite sign, minus tan of pi over 4 times tan of pi over 3, or 2 pi over 3. All right, so let's see what that's going to give us here. So tan of pi over 4, hold on, let me scooch over so I know that I have enough room and I don't run out. Come right over here. Tan of pi over 4 is 1 plus tan of 2 pi over 3, well, that is in quadrant 2, and that means it's going to be negative. And the tangent of pi over 3 is the square root of 3, so this is going to be negative square roots of 3 over 1 minus 1 times negative square roots of 3. Now, of course, we can't leave it like this. Let's just clean this up and see what we have. We have 1 minus the square root of 3 over 1 plus the square root of 3, and we still cannot leave it like this. We must rationalize. And remember, when you rationalize, I'm going to do it over here. When you rationalize, you divide them, and dividing Complex numbers is multiplying by the conjugate of the denominator. So we're going to multiply this by 1 minus square root of 3, 1 minus square root of 3. Okay, you treat it just like imaginary numbers. Okay, so the numerator is going to be 1 minus the square root of 3 minus another square root of 3 plus the square root of 3 squared. That's how I always write it. That way if the number's really ugly, it doesn't mess me up. I just write it in that form, right? And then doing the bottom, I have 1 minus the square root of 3 plus the square root of 3 minus the square root of 3 squared. Now, be careful when you do this. If all of the radicals do not go away in the denominator, you chose the wrong conjugate, okay? So that's a good way of always telling. So those guys cancel. The square cancels the square root. And so my denominator here is 1 minus 3 is negative 2. And my numerator is 1. Okay, let me cancel these guys out as well. So that's the square goes along with this 3. So 1 plus 3 is 4. So this is going to be 4 minus 2 square roots of 3. Now, you can't leave it like that. You got to keep on keeping on here. And so you can either factor a 2 out of the numerator, or you can group it up however you want to do it. So we get negative 2 plus the square root of 3. And so that is what our final answer is. It is negative 2 plus the square root of 3. Okay, so here the trig is not hard. It's some algebra business that's going to give you a little bit of run for your money. Okay, now how can I make this more challenging? Haha. Well, of course, here we go. Here we go. I'm going to give you a cosine alpha with its restrictions, a sine beta with its restrictions. We'll need to draw 2 triangles, and then we can answer those questions over there. So the first thing first, we need to draw our triangles. Be sure to, first off, I always draw my triangles in opposite directions when I do these problems. That way they're very clear, and I'm very clear to label them. Okay, stick in my little right triangles here. Now, let's look at our first one for alpha. Alpha is cosine, which is adjacent over hypotenuse. So we have a 5 here. We have a square root of 5 here. And if you were to do the math, you would find that this is 2 square roots of 5. Okay, we've done this math, so I don't need to be showing you how to do that math necessarily. Sine is negative 4/5. So here we've got 4, we've got 5, and when we do the math there, this is a 3. All right, now I want to state what quadrants we're in here. So the alpha is in quadrant 1. I sometimes just write it in my triangle so I don't forget about it. And this second one is in quadrant 4 because it's going from negative pi over 2 to 0. And so just to visually see that, remember that this is negative pi over 2. So that means we're going this way. Okay, I'm going to actually erase that just in case I need that room. But I wanted to show that to you. All right, so we're set up. We're ready to go. We have sine alpha plus beta. So that is, we're going to go sine of alpha, cosine beta, keep the sign the same, plus cosine alpha, sine beta. That's what we're going to follow there. And in fact, I'm just going to write them all down while my juices are flowing. The cosine of the sum, well, that I know is going to change the signs, right? So it's cosine alpha, cosine beta minus, and then it's going to be sine alpha, sine beta. And here with the tangent, I'm going to write it over here so I can use this space down here. The tangent is going to be tangent of alpha, subtraction, so minus tangent of beta over 1 plus the tangent of alpha, tangent of beta. Okay, all right, now let's work the problems here. So for sine of alpha plus beta, we get sine of alpha. Sine of alpha is 2 root 5 over 5 times cosine of beta is 3 over 5 plus cosine of alpha root 5 over 5 times sine of beta 4 over 5. And then let's just clean that up. So it looks like we have 6 square roots of 5 plus 4 square roots of 5. The denominators are the same, which are 25. So this gives us 10 root 5 of 25. And then when we simplify that out, we have 2 root 5, over 5. Sorry, my brain broke for a second. Okay? Sounds good. Let's do the cosine one then. So the cosine is cosine alpha, so root 5 over, cosine alpha root 5 over 5. Cosine beta 3 over 5 minus sine of alpha 2 root 5 over 5 times sine of beta, which is 4 over 5. So let's see what we get here. 3 root 5 minus 8 root 5 all over 25 gives us negative 5 root 5 over 25 gives us negative root 5 over 5. Perfect. And then let's knock out this tangent here. So we have tangent of alpha. So that is going to be 2 root 5 over root 5 minus tangent of beta, which is 4/3, over 1 plus 2 root 5 over 5 times 4/3. Okay, let's see what we can get here. So 2 root 5 over 5, 2 root 5 over root 5 is just 2 minus 4/3 over 1 plus 8/3. Let's keep on keeping on here. So this is 6 minus 4/3 over, I'm going to write on myself, 3 plus 8/3. All right, and so that's equal to 2/3 divided by 11/3. Stay, change, flip. Our answer is 2 over 11. All right. I feel like something, did I do something weird? Let me just double check real quick because oh, I did. Oh, very good. I knew sometimes things nag you, you know, and you're like, what is up with that? I totally jacked this up. The numerator's great. I knew it was too easy. It should have been way uglier than that. I don't know why I did this canceling here. Oh, because it should have been canceling there, but I didn't write that. Okay, anyway, let's just finish this up. I'm sorry, I don't know what I did wrong. Maybe I didn't do anything wrong, so let's just double check. 1 plus, these guys cancel, and 2 times 4 is 8 over 3. Oh, it was fine, and I canceled it all. I got rid of all of it. Darn it. Okay, so this is 6 minus 4 over 3. So we got 6 minus 4 over 3 divided by 3 plus 8 over 3. And that gave us 2 over 11. Okay. Anyway. Okay, I may look at this later and figure out that there's something wrong. So if you guys work this and you got something different, holler at me because I sure can't see it. All right, so here's another kind of problem that I could ask you. And it is, instead of giving you explicit triangles, I give you one and tell you a quadrant and have you figure out the rest of these things, giving you a second angle to deal with. So let's look at this. If cosine theta is equal to 1 over 4 and theta is in quadrant 4. Okay, so first off, we know what to do when we see that. We know that drill. We're going to make ourselves our little triangle here, call this theta. This is going to be 1, this is going to be 4, so 16 minus 1 is the square root of 15. Okay? And because we're here, we're in quadrant 4. So the sine of theta, so the sine in quadrant 4 is negative, right? So that's going to be sine of theta is equal to negative square root of 15 over 4. Done, done. Okay. Now, let's look up here at the cosine of theta plus pi over 3. Okay, so this is the sum, so what they want us to do here is do cosine of theta, cosine pi over 3, minus sine theta, sine pi over 3. Okay, that's the goal here. All right, and now we're just going to plug in those answers here. Cosine of theta was 1/4 times cosine of pi over 3 is 1/2 minus sine of theta, square root of negative square root of 15 times sine of, that's a pi over 3, looked like a pi over 2, sine of pi over 3, which is root 3 over 2. And now let's clean this up here. Let's see what we've got. We've got 1 over 8 plus 15 times 3 is 45, so the square root of 45 over 2. Ooh, that went crazy now, didn't it? Did I do the sign right? No, I didn't. Oh, goodness gracious, you guys, I need to eat some lunch. I am hungry, and I cannot pay attention if you paid me. I even wrote it down here, and I just totally left that 4 off. Okay, let's get back to it. 1 times 1, the denominators are the same. They're all over 8, so I'm going to do like this, and then I can just put the numerators together. So 1 plus 15 times 3 is the square root of 45. Now we can break square root of 45 down. That is 9 times 5, so that is equal to 1 plus 3 square roots of 5 over 8. Okay, and then let's look at this tangent guy. I'm going to go ahead and write the formula down right here. It's going to be tangent of theta minus tangent of pi over 4 over 1 plus tangent of theta times tangent of pi over 4. Okay, so let's plug it in here. So the tangent of theta is what I've been saying sine was all along, and the tangent is also negative in that quadrant. So the tangent of theta in quadrant 4 is negative square root of 15 minus tangent of pi over 4 is 1 over 1 plus tangent of theta is negative 15 times 1. Okay, so let's see, what do we have here? I'm going to write it like this. Negative 1 minus root 15 over 1 minus root 15. Now those seem very, very, very close, but they are not close. And we will have to take care of them the same way we took care of it before. We got to rationalize that guy. So I've got negative 1 minus root 15 for 1 plus root 15, and then we're going to multiply them by 1 minus root 15 over 1 minus root 15. Okay, and let's do it here. Let's see, we got negative 1 times 1 is negative 1. Negative 1 times negative root 15 plus root 15. Negative root 15 minus times 1 is negative root 15. And negative root 15 times negative root 15 is positive root 15 squared over. We have 1 minus root 15 plus root 15 minus root 15 squared. Let's take care of that. Those guys even cancel. Awesome. So we have 15 minus 1 is 14 on the top, and we have 1 minus 15, which is negative 14 on the bottom. This whole thing equals negative 1. No. Minus 1, negative, no, plus, yes. 15 minus 1 is 14. 1, okay. 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 I must be looking at the wrong problem in my book. I'm not even going to look that close. All right, so there we go. This was an empty slide because I thought I need some more room for rationalizing, so just ignore this. All right, so that brings us to the solving trick for this section. Remember, I told you in the last lecture, or a couple of 3 lectures ago, that for every section, after we, for 8.5, 8.6, 8.7, there's going to be a little section of some very specific ways to solve particular problems that are going to relate to some kind of trick, and also some identities. So let's take a look at this. And for this guy, the trick is it has to be in the form of this. So A sine theta plus B cosine theta equals C, where A, B, and C are not equal to 0. Okay? Now, so this is a trick, and it's very much a trick. It's cool how it works, and if I thought you'd hang on for me to derive it and show you how it works, I would. If you want to know how it works, you could certainly Google it yourself and see how it works, but we don't have time for that derivation here. So this is the trick. First off, we use a substitution method here, okay? And we say that sine phi, that's that symbol, it's the symbol phi, sine phi is equal to the coefficient of the cosine angle over the square root of a squared plus b squared. So the square root of the difference in between those two. Okay? And then the cosine is the opposite. So let's see how this really works. So the first thing we've got to do is we set up these problems. So we say sine phi is equal to, this is our b, right? Our a is equal to 1, our b is equal to square root of 3, our c is actually equal to 1 in this problem. So our sine of phi is b square root of 3 over, and then we have to find this a squared plus b squared. So that's 1 squared plus the square root of 3 squared equals 4. And if we square root 4, we get 2. So this is going to be a 2. And then the cosine of the phi is equal to the a over the square root of a squared plus b squared, which is 2. Now find these. So now solve these problems. Okay, so we'll solve that. So we've got, for this one, phi is going to be, what quadrants are we in where sine is positive? This is going to be quadrant 2 and quadrant 1. I don't know why I said that backwards, probably because my symbol was terrible and my brain went eek. Also because I'm hungry. So our phi is going to be equal to pi over 3 in quadrant 1 and 2 pi over 3 in quadrant 2. And in fact, I think we don't have to find them. We're just looking for the one angle. Yeah, we only need the reference angle, so we don't even need this one. We don't need that one. We only need one of those angles. And then if you notice here, it doesn't really matter what the cosine of phi is, because now to solve the equation, we just need the arc sine. Okay, so once you find out what the phi is, then we just have the arc sine there. So now we can say, so now we solve these problems, we got that. And just for giggles here, phi, if we just solve this one on this side, is also pi over 3, right? So those are the same. They're going to be the same. So once you find one, you got the other. You know that they're going to be the same. You just have to solve one of those. All right, and then we are going to apply this final rule here. So I'm going to say, because we're going to have two answers, right? So I say theta plus phi, in this case is pi over 3, is equal to the arc sine of c, which is 1, over the square root of a squared plus b squared, which is 2. And the other one is going to be theta plus pi over 3 equals pi minus the arc sine of 1/2. All right, so let's just finish solving these guys here. What's the arc sine of 1/2? Remember what that says. That says for what angle is the sine equal to 1/2? We're dealing in quadrant 1 here. So that is going to be pi over 6. So we wind up with the equation theta plus pi over 3 is equal to pi over 6. So that means theta is equal to pi over 6 minus pi over 3, which is negative pi over 6. We could also write that with positive angles. That's how I prefer it. So that would be 7 pi over 6 if you add 2 pi to it. No. It's not 7 pi over 6. Hello, y'all. 11 pi over 6. Goodness gracious, I'm fired. 11 pi over 6, right? Right, this is 12 pi over 6. And here is negative pi over 6 or 11 pi over 6. So there it is, 11 pi over 6. And then let's get the other angle here, which is going to be theta plus pi over 3 is equal to pi minus pi over 6. That is theta plus pi over 3 is equal to pi minus pi over 6 of 6 minus 1 is 5 pi over 6. So let's see, theta is equal to 5 pi over 6 minus pi over 3. And that gives us 3 pi over 6, which is equal to pi over 2. Okay, so our solutions were pi over 2 and 11 pi over 6. Kind of crazy. It's kind of crazy that it works like that. It looks super complicated, but it really, really isn't terrible when you start working the problems. Let me do one more example. I'd give you a you-do, but I think you need to kind of have some direction there to look at right in this minute. So I'm going to go ahead and do this. So the first thing you do is you say sine of phi is equal to b square root of a squared plus b squared. Cosine of phi is equal to a square root of a squared plus b squared. Okay, so let's get that. So that's the first thing we do. All right, and then the second thing we do is we take that angle, we use the phi in this scenario. Theta plus phi is equal to arc sine of c over square root of a squared plus b squared. And, because there's two answers, theta plus phi is equal to pi minus arc sine of c over the square root of a squared plus b squared. Well, since I wrote all that down, let me go ahead and give you a little bit of time to work that. So I'm going to give about a minute and a half and let you guys, do this while I think about my turkey sandwich I'm going to eat. Okay, well, let's see what you turned out to get. As usual, pause if you haven't finished the problem yet. So let's see, sine of phi is going to be equal to 1 over, and this is also going to be 2 because square root of 3 squared plus 1 squared. All right, and so that makes cosine of phi equal to root 3 over 2. But of course, as you notice, you're just not ever going to necessarily have to do both of them. Sine of phi is equal to 1/2 when phi is equal to pi over 6. Cosine of phi is equal to 3 pi over 2 when phi is equal to pi over 6. So those match, so we're in good shape there. And then we're just going to apply this rule here. We're going to say theta plus pi over 6 is equal to the arc sine of 1 over 2. Oh, this is the exact thing. Is this like the exact same problem? No, not quite. And theta plus pi over 6 is equal to pi minus the arc sine of 1/2. All right, so let's finish these guys up here. So the arc sine of 1/2 is pi over 6. So we have theta plus pi over 6 is equal to pi over 6. That gives us theta is equal to 0. And then here we have theta plus pi over 6 is equal to pi minus pi over 6. So that's 0 plus pi over 6. Well, let's just add, oh no, that's fine. This is 5 pi over 6. We subtract a pi over 6 from both sides here, and we have theta is equal to 5 pi over 6 minus pi over 6. That gives us 4 pi over 6, which is 2 pi over 3. So our solutions that we got here are 0 and 2 pi over 3. Awesome. Let's look at these identities, okay? So verifying the identities, the only thing that is left for you to do is to apply the rule and try to make that right side match that left side. So I'm just going to apply the rule on this left-hand side. So the cosine of these guys added are the cosine of alpha, cosine of beta, minus sine alpha, sine beta, plus, we'll do the opposite here. So then this is going to be cosine alpha, cosine beta, plus sine alpha, sine beta. All right, so let's see what we can do with this. So we have a cosine alpha, cosine beta, and another cosine alpha, cosine beta. The sine alpha, sine beta is negative and positive. So, oh, that one was just super awesome. So we get cosine alpha, cosine beta, plus another cosine alpha, cosine beta. So that is 2 cosine alpha, cosine betas. Yay, we got it. Okay. And then let's take a look at this guy right here. I'm going to work with that left-hand side. That cosine is cosine alpha, cosine beta, plus sine alpha, sine beta. That's all over this denominator, which is sine alpha, sine beta. Let's see what we can do with it on this side here. Okay, now do not think that you can cancel these guys. These two don't cancel. This denominator is involved with a bunch of stuff on the numerator, so I'm just going to split them. So I'm going to have cosine alpha cosine beta over sine alpha sine beta plus sine alpha sine beta over sine alpha sine beta these guys here equal 1, and cosine over sine is cotan of alpha, cosine over sine is cotan of beta plus 1. All right, very good. Y'all have a good day.